Hello and welcome to this, our 10th clinic in linear algebra. In today's clinic, we are going to look at the most common method of evaluating determinants, and this is the method of cofactor expansion. So what cofactor expansion essentially does is it reduces a determinant problem, right? So in the case that's on screen right now, it will reduce a 4x4 determinant into multiple 3x3s, right? Which we could reduce each 3x3 into multiple 2x2s if we desired. However, since we already know how to do simple 3x3s, usually we're just going to reduce it down to 3x3 determinants, right, using cofactor expansion. So the idea of cofactor expansion is it doesn't matter what row or column you expand across, you can do any row, any column expansion. So we typically want to look for the most convenient row or column. In this case, it happens to be most convenient to expand, right, across the third row since there are 2 zeros in that row. So now what we do is we look and we go, okay, first is the 3, 1 entry, right? 3 plus 1 is 4, so it's going to be positive. Then that entry, 3. Now what we do is we take the submatrix obtained by eliminating the first column and third row. That leaves us with a 3x3 matrix, and we want to take its determinant. So it'll be times the determinant of -4, 2, -2, 7, -3, 5, then -1, 6, and 9. Well, the next entry is 0. 0 times any number is 0, so we can ignore that one. Move on to 8. 8 is the what? The 3, 3 entry, right? 3 and 3 is 6, that's even. So we keep it plus 8, right? And then we do the same thing, eliminate that row and column. So eliminating third row, third column. We take the determinant of the resulting submatrix. And the fourth would be 0 again. So we're done. Now we just have to take these 3x3 determinants, right? And of course, we know how to do that. So we're going to get 3 times, right? -4 times -3 times 9, which is 108, plus 2 times 5 times -1, which is -10, plus -2 times 7 times 6, which is -84, then minus -4 times 5 times 6, which is -120, minus 2 times 7 times 9, which is 126, and then minus -2 times -3 times -1, which is -6. Then we get plus 8 times 1 times 7 times 9 is 63, plus -4 times 5 times -5, which is 100, plus -2 times 4 times -1, which is 8. Right? Then minus 1 times 5 times -1, which is -5, minus -4 times 4 times 9, which is -144. And then finally, minus -2 times 7 times -5, which is 70. We get 3 times 14 plus 8 times 250, right? And this will give us 2,042. Now this is a 3 by 3. However, if we look, right, at column 3, there are 2 zeros there. So it would actually be simpler just to use cofactor expansion and write this as 2 by 2 determinants. So first entry, 0, right? 0 times anything, 0, we can ignore it. Next up is 6, right? So we get, that is the what, 2, 3 entry, right? So 2 plus 3 is 5, that's odd. So it's actually going to be negative 6. Right, then times the resulting submatrix. And then that third entry is 0, so this just becomes negative 6 times negative 3 times negative 8, which is 24, minus 1 times 5. I don't know why I wrote a 1 there. That should be a 4, shouldn't it? It'll be minus 20. All right, so negative 6 times 4, and we get a determinant of negative 24. So this is going to be just for illustrative purposes. There's no need to use cofactor expansion here. There are no zeros, so most convenient row would probably, most convenient expansion would be along the first row. And so the 1, 1 entry, right? 1 plus 1 even, so it'll be positive 2 times the resulting submatrix. Right? 1, 2 entry, 1 plus 2 is odd, so minus 3, then the resulting submatrix. Right? 1, 3, 1 plus 3 is even, so plus 4 times the resulting submatrix. So 2 times 5 times 9 is 45, minus 6 times 8 is 48. Then minus 3 times, negative 5 times 9 is negative 45. Minus 6 times 7 is 63. I'm sorry, 6 times 9 is 63. 6 times 7, 42. Then plus 4, negative 5 times 8, negative 40. Minus 5 times 7 is 35. 2 times negative 3, minus 3 times negative 87, plus 4 times negative 75. And we get negative 45. Okay, and we'll do just one more. All right, so here we can see the first column has a bunch of zeros in it. So let's expand across the first column. Okay, 1, 1 entry even, so 5. Now what are we left with? The determinant of 2, 1, 1, negative 6, 1, 2, 1, 1, 0, 0, 3, 6, and then 0, 0, 1, negative 1. Now we're going to have to do cofactor expansion again. Okay. Well, let's see. Column 1 has 2 zeros. Column 2 has 2 zeros. Row 3 has 2 zeros, and row 4 has 2 zeros. Of those 4 choices, row 4 seems to be the most convenient with that 1 and negative 1. Right? So that is the what? 4, 3 entry, right? That's odd. So it'd be negative 1, right? But then times that 5, so we get negative 5 times, now what are we left with? 2, 1, negative 6, 1, 2, 1, and then what? 0, 0, 3. That is the 4, 4 entry. That's even, so it's going to be minus 1 times 5. And then what are we left with? 2, 1, 1, 1, 2, 1. And then what? 0, 0, 3. This here should have actually been a 6, shouldn't it? Cofactor expansion one more time, right? Because row 3 in each case gives us 2 0 entries, right? All right, so that's the 3, 3 entry, right? So that's even. So it'll be 6 times negative 5 is negative 30. And then what are we left with? 2, 1, and then 1, 2. Then even, so minus 15 times what you're left with, 2, 1, 1, 2. Then we get 4 minus 1, and then minus 15 times again, 4 minus 1. You get 3 times negative 30 minus 15. That is 3 times negative 45, which gives us what? Negative 135 as our determinant. Okay. So that is the method of cofactor expansion. Right, so that's going to conclude today's clinic. The next clinic, we'll be concluding our look at determinants by looking at an application, specifically Cramer's rule. All right, I will see everyone then.